Moving to the final question for today, which is from the hard bucket. So here's the problem. So the problem is longest chunk palindrome decomposition. The name sounds very intriguing. The problem is a bit simpler than its name. So you have to find the largest k. So k is the length of some groups that you have to create, and the groups in concatenation should return the entire text that has been given as the input. But the condition for creating those groups is your groups, suppose the first group should be same as the last group. And if we move ahead with the second group, it should be same as the second last group. Okay. And then we have to find out how many groups, the maximum number of groups can we create. Let's take this example. So here we have this string ghi something something, and it's a long string, and we can break it into 7 groups. The first group, you see ghi is same as the last group ghi. Then the second group a b c d e f is same as the second last group, and that we can move ahead with the same approach, and then we'll find something if we have nothing split a common between. So if you consider this from the palindrome point of view, each word or group of these number of groups, and each group in itself will create a palindrome. Let's represent this ghi as a. So you have first and last character as a, then you have b and b, then you have c and c, and there's a d in between. Okay, so instead of a single character for finding palindrome, we have to find a group of word that will create a palindrome, and the length of this palindrome has to be maximum. Is the problem statement clear?
Yes.
Yep.
Okay. Anyone tried this already? Or any ideas for this one?
Yeah, I did it.
Right.
So what I did is take 2 pointers. One is starting from the very left, pointing it to the first G, and one point to the right, extreme right, and start comparing both. So I will not move my left pointer unless I find a character which is matching to my left pointer. So I move only right pointer toward the left. So once I get G is equal to G, now I already have stored my right limit, how far I can move my right pointer before starting my right pointer traversal. So I need to move right pointer to the right limit, which is pointing to my I when I started my traversal. So basically I'm just checking if GHI is equal to GHI. If yes, then when I start traversal of right pointer, like if I get a comparison G is equal to G, I also need to have a pointer which is where I need to reset my right pointer after I find the comparison or after I fail in my comparison. So that the next right pointer of my traversal will point to F. So basically I will start comparing. If I pass, I need to move my right pointer to F and left pointer to A. And if I fail, I will keep my left pointer at G only. That will be a reset pointer, and continue reducing the value of right pointer.
Until what can you reduce your right pointer?
So let's say if I take the same example GHIABC1, so my left pointer will be at G, right pointer at I. I will have a left reset pointer which will be also pointing to my G. I will have a right limit pointer which will be pointing to I.
Okay.
So now I start my traversal, and I also need a next pointer in case I find a comparison like my left string, like GHI is equal to GHI, where I should start comparing A to. So my A will start comparing to F now after I find that comparison, right?
Let's assume this as a input string.
Small example. Okay.
I'm just trying to do this. So you have your left pointer here, right?
at G.
G.
Yeah.
And then you start from the right and then to try to find the G,
G. Yeah.
correct?
So my G is equal to G. Now
Right.
I also have a left reset pointer in case I fail in my comparison, where my left pointer come back to.
Okay. So this is your, okay. So it's a saved index where you can come back if the comparison fails.
If my comparison fail. And
Now you have G,
the
H.
criteria for comparison fail is like I not able to reach to the right limit. My right limit is pointing to C from where I started.
Correct. So now let's assume there's U here.
Yeah.
And then you start from G. Okay. Let's reset. And then you find a G here, right?
Yeah.
And you'll start comparing it again. You know, start from here and this.
Yeah.
So my question was, is it really useful to look at G, which is here? Will you ever find a, you know, starting string and ending string which is having same, just cross the halfway mark?
Yeah. Not required actually.
I'm just trying to, you know, your approach, it's okay. It's fine. I'm just saying, you know, you can probably optimize it a bit further by not looking anything which is beyond your n/2 mark.
Yeah.
Right. And okay, what would be the time complexity for this approach?
I think currently it will be order of I'm doing n comparison and order of n square, but less than that because I'm not doing always all the comparisons. So if I'm starting comparing G to C and moving to the left, but I'm again doing everything. So n into n/2, I believe so. N square,
N
it
square
seems
in
in
this
the worst
kind of.
case, yeah.
It will be
But
n
I can
square in this
optimize
kind
it.
of.
Yeah. What I did to optimize it is whenever I'm traversing from back, maybe I can store the string in the reverse order. That will help me in comparison instead of traversing back character by character to reduce the complexity. Yeah, but
Any other approach?
I was thinking of I mean taking no space, so that's why. Yeah.
For example, you write on the board. What's the return result of this example? I think it should be 1.
Yeah.
For this one?
Yeah, this one.
Yeah, it is 1.
Okay.
Yeah, any other approach? Any other suggestions? If we can do better than n squared.
My approach is O of n. I just use one pointer I to iterate the whole string. Yeah, and I also have two string. One is the first, one is the last.
Okay.
First string and last string, and I use the for loop to iterate the whole string. Yeah, and the first string equals first plus this is test I. Yes, test I. And the last string equals text m minus 1 minus I plus last.
Okay.
Yes. Yeah, and we use the if condition. If the first equals last, that means we found the same string at the beginning of the test and at the last of the text. So we will aggregate the return result at 1.
And what will be the aggregate value?
Yeah, aggregate, maybe we return the result or answer, we use a count to count how many groups, how many palindrome groups in that text. Yeah, we aggregate the result, the count by 1. Yeah, if count. And at that time, we we update the first and the last to be an empty string. Yeah, this is also in the if condition. Yeah.
Yes, understood.
Yeah.
And then count is your result, right?
Yeah, we will. Yeah. And yeah.
You're doing it again for 0 to last element, right?
At the second for loop, the I will become to 1, 2, 3, and we get the string in the middle of the text, and we will compare on and on. Yeah,
So what I'm saying is, do you really need to go to the last element for I?
Yes. Go to the last element. I think.
Let's assume your I is here.
Yes. Go to the last element. Yes.
Let's take this example where your I is equal to, suppose that this is the 0, 1, 2, 3, 4, 5. Okay. So what will be your first? Your first will be equal to GH GI UB. Your last will be equal to C.
The last is not C, I think, because the last is aggregate from the C, B, U. Yeah, it's C,
That will
B.
be H G I U B C, right? The 5 characters from the last.
Yes.
So coming to the same point which we were discussing earlier, if you have crossed the halfway mark, will you ever want to consider these two scenarios where the first and last are overlapping or crossing each other?
Yeah, that means in this situation, your last example will return 1 because there is no first and or last string equal to each other. So the last example return 1. Yeah, and we go to your current example. Is there 5A? Yeah, we can try. Yeah. And when I equals 0, there is no the first not equal last because first is B, last is A, and we go to the I equals 1, and the first equals BA, and the last equals BA, and we will get the count equals 1.
All right, so I was just checking if we can just go to the halfway mark and it will still do the work for us.
Yeah, I think we can go to the last. Yeah, we can try. Yeah, once we go to the I equals 0, 1, 2, 3, 4. Yeah, we also can get the correct answer.
Because we don't need to go after the half. Anyway, your first half will max be this one. If you are not able to get first in the first half and then match it with something in the last,
yes,
it anyway is not going to be a palindromic number. Right?
Yeah, we just need to go to the half of the string. Yeah, half of the text. Yeah, when we go to the BAA, yeah, that's enough. Yeah, you're right. Yeah.
Has anyone tried this with the dynamic programming approach? I know when I looked at this problem, the first approach that came to my mind was the dynamic programming. If we have to do this with dynamic project programming, could someone, help us out, help me out with the recurrence relation, or what will be the DP equation for this? I think we still have some time. Yeah, we have. Guys, any idea, any guesses on the DP approach? Sorry if someone had asked any question in the chat. Let me just check. There was a question related to KMP. Roger, would you like to cover that up? I'm not sure I was discussed about that.
Yeah, so since we are kind of doing pattern matching, I think the question was, at least what I could think about that, can we use KMP to do the pattern matching because it will be faster? And of course we can. I at least for me, it is easier to come up with generating a hash using a number. And so I used a Rabin-Karp algorithm. As long as there is no collision, it is almost equally performant. So like, for example, in this case, for GHI, suppose you can assign each number G, H, and I a number, unique number, and you can generate a number based on that from going from left side to right side. Similarly, when you are generating number I, H, and G from the right side, and you can generate a hash in the similar manner, because now you have GHI, and you are just comparing those long or int, you are comparing two numbers. You can just you are not again doing anything with a string. You are now comparing numbers, so you will achieve the better time complexity of number of elements in that string. So that's the idea. Let me check. There are another comments here in the chat.
Yeah, I think what Monish was trying to say, if we can use the LCP array, LPS array that is created for KMP,
right?
this prefix array. One thing, Monish, I don't know if he's on the audio bridge, but one thing is, once you have found out the first, the smallest LCS on each side of the string, then you will have to do it again for the entire string, because LCS will give you a pattern, common prefix and suffix from starting until endpoint, right? Then you'll have to calculate it again based on the new, pending string. So suppose in this case, once we have out of GHI, then your remaining string will be this one. And then you'll have to again calculate that LCS for the LPS for the remaining string, right? That's what, I think Roger was trying to say. It's better, easier to, or faster to calculate the hash, rolling hash, as compared to LCS array to calculate what we can in order to move. And again, one more thing, LCS will give you the longest set, right? In this case, because we are trying to find it using a greedy approach, we want the shortest prefix and suffix match first, so that if there's a common string in between, that will create its own set and the numbers will increase, right? Does it make sense? Okay. Yeah, Roger, sir, go ahead if you are saying something.
No, I'm fine. I think I was so the Muniz used to talk to us, because it's very we can't check the chat while we are working on the problems, and especially if you are on phone, we can't even look at it. So yeah, if you have questions, jump in and then suggest, we are always like, welcoming better suggestions. For me, I haven't coded KMP in a while, so it is possible to do it. I'm pretty sure because it is one of the fastest algorithm. But for me, like hashing is very natural, it's like math. So I can get that thing, working faster. It works in this case. So that's why I suggested that solution. But yeah, feel free to use KMP. Should work.
Yeah. So Manish, what Roger was saying, where we are actually, taking the strings one by one and then comparing where we could actually create a rolling hash, for the comparison part of it. That will be faster, and we don't have to actually every time take the substring and then compare, which is of n operation. Instead of that, what we can do is while we are iterating, we can create a rolling hash, uh, and that's part of the Robin Karp algorithm, which Roger was saying. And then once we find a hash match, then we can actually go ahead and try to see if the strings are actually same, because the hashes can be same, but the strings cannot, may not be because of the hash collisions.
I think he's asking, can you please iterate once for hash? Do you mean like, run a sample, like, how we would do it, how we will generate the number? If that is the question, I can try. Like, working on the screen. But is that the question, first of all? Yes, or on a small string. Okay. So let's run it on GHI from both sides. Can you share the screen, Puneet? Let me try.
Are you, or should I say?
Oh, you want to do that? Yeah. So let's have GHI, then write dot 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 GHI dot dot, we don't care, and then GHI. So from left side, when we are going, we have assigned each alphabet some number. Like, you can,
Roger, just one
yeah,
second. I just wanted to give it, a bit easier representation if we do
sure.
it in numbers, like 1, 2, 3, and then dot 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 and 1, 2, 3.
Okay.
So if we can just, that probably because then just the base is changing, right? This is a base 10 number, and this will be a base, suppose 26 if we are considering only
Mm-hmm.
uh, small case numbers, right?
Right.
Okay. So if we are reading, there are two ways. We are reading from left to right, and then we are reading from right to left.
Right.
Now here we have 1 as the first one, and there we have 3, right? If we move one step ahead in both sides, so what we'll do is 1 into the base plus the next number,
Yeah.
right? And here what we'll do is take the number, whatever is the new,
Mm-hmm.
right?
Exactly.
Into base raised to power this index. Suppose in this case it's 1,
Plus 3.
and then plus them 3,
Mm-hmm.
right? In this case 2. So it will become here 12, and this one will become 20 plus 3, which is 23, right? And then we do the same approach when we move one step ahead. 12 into 10 plus 3, which will give us 123. And same way here, right? 1 into 10 raised to power 2 plus whatever we got from the last step.
Exactly.
123, right? I am just doing it on integers because it's easier to understand. For this case, it's exactly same. The only difference is the base here is 10. It changes from 10 to 26 in this case because there are 26 characters. And the other thing is, because the powers for 26 can go very high, we usually convert them into some kind of modulo function so that the results are within the bucketing range of modulo, right? And that's why we're saying, if we still see hashes same, we still need to compare the strings afterwards.
Right.
I hope it is clear now.
Yes, it's clear. Great. Thanks, Puneet.
Okay. Okay. Um, any other approach, anything, Roger, Vivek, from your side?
I think you wanted to share a dynamic programming approach. Do you want to go ahead or?
Oh, yeah. Let me just share the whiteboard. Yeah, anyone has any idea what we can do with the DP? So what we can do in this DP, I'll just you know pictorially represent it, and then probably we'll go ahead and try to create an equation out of it. So we have some string, okay, and then we have part of string for the start and end. Right, what we are doing right here is in this approach is we are trying to find the smallest one which is matching, correct? Right, and this approach we can do for everything. So it's not necessarily like we have GHI, here we have GHI. We can have another GHI here, like GHI and then GHI. This will also form a valid, the start to end combination matching, right? So what we can do is we can keep iterating over the array from left to right, okay, and trying to find what part of the start is matching or the prefix is matching with suffix, and then reiterate over the remaining part. Does it make sense? This we can do till we are able to just meet at the middle and there's no element left to recurse. Now, if you do this, you'll find that this is what I experienced when I did with the DP. I found that always the answer was when I had this smaller first element chosen. And then everything else was giving me lesser numbers because I was already reducing the numbers which could have been generated because of this and this, which are again the same, right? GHI here, GHI here. Essentially, kind of recurrence equation becomes, if you have a function called function from I to j is equal to function of a comma b, and considering I to a is equal to b to j and 2 plus. Right, because the two are the numbers which are created when I'm considering here and here. And I can use a max function over all the numbers. And for faster approach, we can actually, cache the results from A to B, whatever is the, I to J, we can cache them so that we don't have to, calculate the same thing again and again. Does this make sense? The DP approach? I hope it is clear, guys. Okay, I'll assume everyone understood it.
Yeah, makes sense.
Okay. If we don't have anything else, I think we are almost in time today.
Yeah.
Anything else we want to discuss, guys? Anything, not just from this one, but anything else you want to discuss? I'll stop the recording for today and then we can continue discussion if we have anything. Thank you guys for